The aircraft industry is booming these days with the air journey becoming increasingly safer. There are around 8,000 aircraft flying in the air at any given time. But none of us has ever faced a problem of air traffic thanks to the radar technology. So, what is radar? Radar, initially coined by the United States Navy as an acronym for radio detection and ranging, it is an object detection system that uses radio waves to determine the range, angle, or velocity of objects. It can be used to detect aircraft, ships, spacecraft, guided missiles, motor vehicles, weather formations, as well as terrain. So let's see, how does a radar system work? A radar system consists of a transmitter producing electromagnetic waves, a transmitting antenna, a receiving antenna, a receiver, and a processor to determine properties of the objects. Often the same antenna is used for transmitting and receiving. The radar transmits pulses of electromagnetic waves, mainly in the radio or microwave domain, by means of a directional antenna. Some of the pulses are reflected by objects that intercept them. The reflections are then picked up by a receiver, processed electronically by the processor, and converted into visible form by means of a cathode ray tube. The range of the object is determined by measuring the time it takes for the radar signal to reach the object and return. Velocity of the EM wave multiplied by half the time taken between transmission and reception gives the distance. The object's location with respect to the radar unit is determined from the direction in which the pulse was received. Velocity of the object is measured by applying the Doppler principle, which is, if the object is approaching the radar unit, the frequency of the returned signal is greater than the frequency of the transmitted signal. If the object is receding from the radar unit, the return frequency is less. And if the object is not moving relative to the radar unit, the return signal will have the same frequency as the transmitted signal. So this is how a radar gives information about the object's location and speed.
Radars are thus used in many different fields where the need for such positioning is crucial. The first use of radar was for military purposes, to locate air, ground and sea targets. Various radar tracking and surveillance systems are used even today for scientific study and for defense. This has evolved into the civilian field into applications for aircraft, ships and roads. In aviation, aircrafts are equipped with radar devices that warn of aircraft or other obstacles in or approaching their path, display weather information, and give accurate altitude readings. Such aircrafts can land even in fog at airports equipped with radar-assisted ground control approach systems. Marine radars are used to measure the bearing and distance of ships, to prevent collision with other ships, to navigate, and to fix their position at sea when within the range of shore or other fixed references such as islands and lightships. In port or in harbour, vessel traffic service radar systems are used to monitor and regulate ship movements in busy waters. Meteorologists use radar to monitor precipitation and wind. It has become the primary tool for short-term weather forecasting and watching for severe weather such as thunderstorms, tornadoes, winter storms, precipitation types, etc. Hence, radar found various important applications in various industries as well as military.
Created using Powtoon.